What this will be is a review of material getting you ready for a placement exam, or in a sense a review for a final exam in preparation for college algebra. So looking at the first example and then developing a strategy for doing this, what you'd want to do is to write the example down, give it a try, and then play to see what the protocol is to get the correct answer. Now, what I'm saying here is to be careful, because often you may not be answering the question the test makers are asking. So for instance, in this first example, we could call it number 1 or whatever, we have a quadratic equation in standard form. And they're going over what standard form is. In some cases, you have to identify what the a term is. That would be the coefficient of the x squared. And when there's nothing written there, there's a 1. So a would be a 1 there. Now your b is the coefficient of the x term, which is a negative 16. And your c term is the 64. Now what they're asking you to do here is to factor this equation in standard form and then put the factors in here. So let's factor that. Setting up a prototype here of when we factor a quadratic equation when there are 3 terms. Now, for 1x squared, the only possibilities for the first spot is x and x. Now, we're looking for 2 factors of 64 that will add up to a negative 16. Well, that's sort of easy. A negative 8 and a negative 8 will give you a positive 64 when you FOIL this, and when you do your outers and inners, it adds up to a negative 16x. So this is what you would put here. Now, there is a 2-step part to this. They're then asking you to say, what are the values of 8? I don't have that written here, but you would then equate each of these factors to 0 using a shortcut here. So solving this, the negative 8 goes to the other side as a positive 8. So you get here x equals 8. And here, since it's the same, x equals 8. Now, when you get 2 answers that are the same, you only need to write it once. Another review item might be what's on the left side of the equation here. This is a perfect square trinomial. All right, let's go on to our next part. Now, here we have a word problem, so take time to read it carefully. And they're also giving us the systems of equations to solve it. So rather than having to set the equations up yourself, they are giving the equations. What you are to do is figure out what method would you use to solve it. Well, one of the things I would do is get rid of the decimals here. So I'm going to rewrite this without decimals. So this is going to multiply everything by 100. And I'm going to put 2 decimal places there. So multiplying each of these terms by 100, I get rid of my decimals in each of the terms. So my new equation now is 6x plus 2y equals 430, and then adding my other zeros. So that makes it a little easier in your computation. Now, here they're telling us what x is. X is this. So the method I would use, wherever there's an x, I'm going to substitute y plus 1200. So there's my x. I'm going to erase it. And I'm going to put here now the substituted value, y plus 1200. Didn't give myself a lot of room there. Now I have an equation with only one variable, so it's a little easier to solve. So take a moment to expand this parenthesis and see what you get. Now, when I distribute this, I get this. I'm going to collect like terms now and get, let's put it over here, 8y. Now I'm going to subtract 7,200 from both sides, or just take this term on this side, it becomes a negative 7,200. And when I do that subtraction, I get 35800. Now I'm going to divide both sides by 8 to solve for the y. And this is y equals 4,475. So you'll notice the x is 6%. The y is the 2%. So where do I put this? Well, this is the y value. It goes right here. And then what would be the other amount? Well, if I add 1,200 to this, I'm going to get what x is. So this will be 5675 as I add 1,200, and there are my answers. Again, reading it carefully, they helped us out by giving us the equations and then solving and remembering which value goes where, because I've seen students sometimes put them in the wrong place. Again, they're giving us a word problem. The point, pause, read it carefully. And in this case, again, they're giving us the equations. So we're asked to use this formula to find the number of boxes of paper clips. So the protocol would be to clear parentheses. 2 times 31 is 62. Now, reviewing one of the other methods, if you're not transposing, taking a term from one side to the other, just changes its sign. A more traditional way is to do it like this. Subtract 62 from both sides. And you would get x. Here this adds up to 0. And this adds up to 17. So again, something relatively easy. The more challenging part here was to put the words into the equation. In this example, they're asking us to subtract this from that. So what's the strategy operating in the background? Well, when you have a negative sign in front of parentheses, the protocol is to change the sign of the term inside. So let's rewrite this. So x squared minus 3. Now changing each of the signs, this becomes a negative 6x squared. And then this becomes a negative 8. Again, a common error is the students will just change the first term and not each of them. And now it's a matter of, you can line them up vertically, which is a good idea, I think. Negative 6x squared. And then this is going to be a positive 1x squared. Remember, we don't write the 1 normally. I would suggest you do it when you're doing calculations. And then we have a plus 8 and a minus 3. So here you're going to end up with a negative 5x squared and a positive 5. Here we have a traditional equation. It's just to the first degree. Our exponent is a 1 that we don't write. And we're asked to solve. Now, the easiest way to do this would be to subtract 14 from this side and 14 from that side, or transpose the positive 14 to this side. It becomes a negative 14 on that side. And we get a negative 2c equals a negative 18. Now, there are different ways to do it. You could have moved the z over and got positive z's, or there's, again, different ways. But now we want to get a positive 1z by dividing this side by the coefficient, which is a negative 2. Anything divided by itself gives you a 1, except for 0. So we get a positive z is equal to a positive 9. Negative by negative gives you a positive, and 2 goes into 18 9 times. Now, in this example, they're asking us to multiply these binomials by using the distributive property. Now, we could also have FOILed here, but let's use the distributive property. That is, take the first item here and multiply it by the second binomial. Then we take our second item there and multiplying it by the second binomial. Now we can distribute. Here we get a negative 6x squared, a positive 6x. Here we get a negative, well, negative times negative is a positive 10x. And here this will be a negative 10. Now notice we get two like terms internally. And we'll summarize that. Negative 6x squared plus 16x minus 10 when we do it this way. Now let's use this as an example for FOIL as well. And we'll write that here. Now when we FOIL, we do the first two terms. That will be a negative 6x squared. Then we're going to do the outers. Mentally, it's a positive 6x. Then a negative for our inners times a negative gives us a positive 10x. So that adds up to a positive 16x. And when we do our last, we get a negative 10. So again, illustrating this in two ways. In this example, we're asked to expand this. Now, notice this part of it, we're going to use the powers rule. So we'll do it in steps. It's 4 times. Now, keep in mind there's an exponent here. This is negative 4 to the first that we're going to square. So this becomes a positive 16. And then 4m, m to the 4th power times 2 gives us m to the 8th power. And then now, it's just a matter of distribution. 4 times 16 is 64, m to the 8th. Again, the powers rule first, and then distribute. Now, this next example relates to one we did earlier. And as you look at it, you might think, well, multiply. But no, they're not asking you to multiply here. That's why you have to be careful of what they're asking. They want you to factor this by factoring out the common binomial. Now, as we look at it, here is the common binomial. So we're going to factor that out. 3x minus 5. Now, to get to this from an earlier example, this was here, 8b squared. And then we had a negative 7a. So if we were going to multiply these two binomials by using the distributive property, we would take this and multiply it by that, which is what's here. And then we would take this and multiply it by that, which is what's there. So again, you have to read carefully the instructions. Otherwise, you might be doing something that's mathematically okay, but not answering the question they are asking. All right, let's just, without moving it up, do this next one, because it's just a division problem dealing with fractions here. 2 will go into 10 5 times. And the strategy for dealing with exponents is when the 2 crosses the division bar, the sign of the 2 changes, becomes a negative 2, and we get y to the 3rd power. That is, just subtract 2 from the 5. This example deals with your skill of graphing. Here is an equation in slope-intercept form. Y equals mx plus b. And you may know a number of ways to solve this and techniques for graphing, but here they're specifically asking for two ordered pairs that satisfy this equation. So in a situation like this, the best tool would be a little t-chart. And what values can we put for x? Well, we said always you could use a 0. And then we could use something, since our slope here, m, which is 1/2, is a fraction. We want to not have fractions in our answers. So we're going to use numbers that would be multiple of 2. Now we could use a 2, but to give us a little more room, let's use a 4, which is a multiple of 2. So if x here now is 0, 1/2 of 0 is 0, our y value would be 3. And if x is 2, putting a 4 there, 2 goes into 4 twice, so this value becomes 2. 2 plus 3 is 5. So this is what we'd put down here. 0, 3, and 0, 3 is right there. And once you do that, in the software, it actually puts the points in for you. And this is going to be 4, 5, which is over 4, up 5. So there's our 2 points. We take our line tool, and then a nice graph forms. Not doing that too well, am I? There we go. That's a little better. Okay, when it's done in the software, you get a nice straight line. Now, while we're here, let's review the other method of graphing. We said our b value, when it's in this form, is the y-intercept. That is, where the graph will cross the y-axis. And it crosses it at 3. 1, 2, 3. Look at that. And we set our slope, which is the m value, is 1/2. And that's a ratio of y units over x units. So if from our y-intercept we go, and since it's positive, we're going to go over 2 units and then up 1, it brings us to this point. Or we go over 4 units and up 2. So again, there are different methods to solve something like this. We're giving you a general review. In this example, we're asked to divide a trinomial by a monomial. And the protocol for this is to write each of the terms of the trinomial over the monomial. So I'm going to put each of these over x to the 4th. And then now what we're asked to do is to simplify. Well, here we're going to subtract 4 from the 5, and we just get 3x. Because there's a 1 there, and 1 goes into 3 times. Now here we notice this term is going to be negative. Now, since the 3 is smaller than the 4, we're going to leave the 1 up in the numerator, bring the 3 down, it becomes a negative 3, and we just are left with x to the 1st. We don't write the 1 when it's just to the 1st power. And on this last term, there isn't anything we can do. and we just leave it this way. So we have done what they've asked. We've simplified this into this. There are no more common factors. Now, in this example, when we have systems of equations and we're asked to solve it and determine whether the system is consistent, inconsistent, or dependent, and they're asking us to solve by substitution, what we should always do first is inspect these and see if we can get any clues to what's going on. So we have suggested that you write the equations out over here to the left of the paper. Now, as I look at these, I want to see if I could develop something here, and I have an idea. For instance, if I divided this equation, every term, by a 7, I don't have the same equation, but it's equivalent. And then what do I get? Well, I get a negative x plus y equals a negative 1. Now, if I divide this equation, every term, by 6, I then get, and I usually put an arrow here to indicate, and I would write it next door, but I'm leaving this so you could see it, a negative x plus y equals a negative 1. And you might say, wow, even though these equations initially looked quite different, they are the same equations. Oh. So if they're the same equations, what do we choose down here? Which word? Well, the same equations is they are dependent. Now, if we got, as a result of this, this left side would be the same, but the right side would be different. These equations would be equations of parallel lines, and there would be no intersection. And if this didn't come up and we had to use some other kind of system, what would it look like? Well, you would probably get that x equals a value, like say 4, and then y equals a value that is 2. That is one point of intersection, and then that would be consistent. Okay, we had one in which we were figuring out interest that had that one point of intersection, where we found the value for the y as some money and the value for x was some money. In this example, they're asking us to determine whether these lines are parallel, perpendicular, or neither. And you might say, how would you go about doing that? Well, we said if you put them in slope-intercept form, solve for the letter y, you can then compare the slopes. If the slopes are the same, but the y-intercepts are different, the lines are parallel. If the slopes are different, but one is the negative reciprocal of the other, giving you a product of -1, then the lines are perpendicular. And then if neither of these are true, then the lines would be neither in relation to each other. So let's solve each of these equations for y. So y on this one equals, I'll just transpose that, and that becomes a positive 32x plus 10. And then for this one, it's y, 4y equals 8x plus 6. Now, solving it for y, I'm going to divide both sides by 4, and I get y now equals 2x plus 3/2. Well, here, comparing the slopes, this is a 32, and this is a 2, so they're not the same slopes. One's not the negative reciprocal of the other. So, in this case, these equations' relationship to each other would be neither, not parallel, not perpendicular. Going on now, we want to find an equation in slope-intercept form. Y equals mx plus b with a given point and a given slope. So what we could do is substitute this information into this equation. Now our y value here is going to be a -3. Our m value is a -3/2. Our x value is 1. What we don't know is what the b value would be. So we're going to solve this equation now for the letter b. But notice we have a fraction. And there are 3 terms. If we multiply each term, and I'll change colors, by the lowest common denominator, which is 2, I get rid of the fractions. So here, if I cancel out the 2's, I now get a -6 equals a -3 plus 2b. Now I'm going to add 3 to both sides, or transpose this, and this becomes a -3 equals 2b. Divide both sides by the coefficient of b, and I get b equals a -3/2. So in writing my equation, y equals mx plus b, I have y equals, I know my slope already, a -3/2 x. But now I have what my new b is, a -3/2. Testing your skill in solving equations, we go to our next example. We want to collect like terms. So remember, when there isn't a number by something like this, there is a 1 there. We just don't write it. So a -1y, -2y gives me a -3y. And then just collecting these, I get a -27. Dividing by the coefficient of y to get a positive y, I get y equals 9. Now here we're using the Pythagorean theorem, and I'm going to go back to red. I like red. And they're giving us values for C and A. They want us to find what is our B value. Well, the formula for the Pythagorean theorem is a squared plus b squared equals c squared. So we have side A here. Call this side A. This is side B. A squared is 100. We don't know what b squared is, but c squared is 144. So we're going to transpose the 100. On this side it becomes a negative 100, or subtract 100 from both sides. We get b squared equals 44. Now, when we take the square root of this side, we're left with b, and then the square root of this side, we get the square root of 44. Now, this is the exact length, but they're asking us to convert this, and we could do a couple of things with it, depending on which level. I can divide that into the square root of 4 times the square root of 11, and the square root of 4 is 2, the square root of 11. But now put that in your calculator and see what value, and they want you to round to 3 decimal places. And the protocol for this would be to look at the 4th decimal place, which is a 2. Now, the rule for rounding is if it's 4 or less, you drop. If it's 5 or more, you drop, but then add 1 to the next digit. And here we would just leave this as 6.633 as what side B is. Now, we do get some easy ones. Here we have just to transpose the 15 to the other side. So we get V equals 15, a negative 15 on this side, plus 6. So V is going to be a negative 9. Now, for this, they're asking us to factor. It's in standard form. There's no common factor, so protocol would be to put 2 parentheses, and you're going to undo the FOIL. So for our first term here, an x and an x, and then factors of 40, a negative 40, that give you a sum of a positive 3. Well, I happen to know 8 times 5, after mentally going through various factors, and if 8 is positive and 5 is negative, and if we FOIL this, it checks out. Let's do it together. X times x, x squared. Outers, a positive 5x. Inners, a negative 5x. That adds up to a positive 3x. And then last, negative 5 times 8, a negative. Just 2 more to go. Now in this, again, this is a systems of linear equations, and they're giving you the word problem, and they want us to solve these graphically. So what's the protocol? Well, the first thing they want you to do is to put these equations that are in standard form into slope-intercept form. So once again, y equals mx plus b. So if we do this first one, we get 2y I'm going to transpose the 2 to the other side. The 2x becomes a negative 2x plus 110. Divide everything by 2. And we get then, let's write it right down here. Well, y equals a negative x plus 55. So there's our first equation in slope-intercept that I'm going to put here. Now, in a sense, this is a negative 1x. Don't put the 1 in, just leave it like that. And then this is plus 55. Now, this equation, I'm going to move the y over to this side, and I get a positive y. And I'm going to move the positive 25 over to this side where I get a negative 25. So there's this equation. So again, there's a 1 in front here that we don't write. So we don't write anything in this box. And then here we're just going to put, we could put it in parentheses or not. It's all right. And there's our two equations. Now, to plot this, when you're using the software, once you do this, these lines will form. So I'm going to pause here and go to a program that will help me graph this as if it were. And the program I'm using is one that's called desmos.com. It's something I treat in another video, but we're able to put in equations that we have, and then the lines are forming. Now, this is the first one where the slope is negative, the red line, and then the blue line is where the slope is positive. Now, we can't see the y-intercept of both things, but we do see the y-intercept for the second equation here as a negative 25. And up here would have been the, if we saw it, the positive 55. And one slope is negative, one slope is positive. So they intersect at this point right here. So we've put the equations, and we can go back to show you those. Let's see here. Well, I guess we can. So anyway, there is the point of intersection. So what is that point? Well, we need an ordered pair. They are consistent, intersect at least one point. So our x value is 40. And our y value, if we go from here over to the y-axis, is 15. And we solve this by graphing. So we'd put these values, click on consistent, and put them here. Actually, there's a few more examples. Let's go on to this one where we're going to substitute these values into this expression. So our x here is 0. Our y is a negative 3. And then this is squared. And our z is also a negative 3. So a negative 3 squared is a positive 9. This is a negative 18. And this gives you a result of a negative 9. Now, for this next one, we're asked to factor this. We notice we could take a 3 out of both terms. And then what's left in the parenthesis can also be factored. I'm not sure you can recognize this, but this is the difference of two squares, and the difference of two squares factor into their conjugates, which is or are x plus 3, x minus 3. So this is the product of the sum and difference of the same terms. These binomials are referred to as conjugates, that when you FOIL them, the middle term cancels out, and you end up with the difference of squares. All right, let's go on. Almost finished. In this example, we're asked to look at this figure and decide what formula would we use to solve. And the answer is, this is a trapezoid, and this is the formula for a trapezoid. It's in 3 parts. The next thing is they want you to take this formula and solve for the letter H. Well, since this has fractions, and on this side is one term, and because of the multiplication, this is all one term. We multiply each term by the lowest common denominator, which is 2. So here the 2's cancel out. So I'll just use my eraser to get rid of this. And then now we're asked to isolate the H. Well, to do so, we divide both sides by this factor, and we don't need to use parentheses on this side, or you could. Here, this cancels out, and we're left with H now equals 2a over b plus c. But we're asked now to solve. The trapezoid area is 7. So area here would be 7. 2 times 7 is 14. And again, we're solving for H. And our B is 5 and 9. So that would be 14. So our height here is going to be 1. Okay. And for our last one, we did one like this already, where we used the Pythagorean theorem, a squared plus b squared equals c squared. Well, a squared is 3. Let's put it this way. This is 9 plus 16 equals c squared. This is 25 equals c squared. Take the square root of both sides, and we get c equals 5. And this is that famous 3, 4, 5 right triangle. Okay, hopefully this is helpful. It's meant to be a little review of the kinds of things we'll be doing. And good luck with your course.